Hey everyone, and welcome back to the channel. This diagram lays out a pattern for setting up efficient machine learning experimentation environments. It shows how data flows, how different stages are linked, and how to structure your workflow from initial idea to potentially production-ready code. It all starts with data, right? We typically begin with raw data. This is data straight from your sources, messy, inconsistent, maybe in various formats. A crucial first step, often part of a data engineering pipeline, shown by the pink line, is transforming that raw data into curated data. This means cleaning, validating, and structuring the data into a more usable format. This could involve big data processing tools like Spark or Dask. Even more important for ML is the feature store. This is where you store curated, engineered features that are ready to be used directly by your ML models. Think of it as a central, reliable place for features like users' average login time or products click-through rate. Why is a feature store key? It ensures consistency between training and serving and makes features easily discoverable and reusable across teams or models. Now, let's look at the core ML training pipeline. This sequence is repeated in different environments shown here. It starts with data retrieval, pulling the necessary data or features, ideally from the feature store or curated data. Next is pre-processing, scaling features, handling missing values, tokenizing text, etc. Then comes model training, where you actually train your model on the prepared data. Model evaluation follows, measuring how well your trained model performs on metrics like accuracy, precision, recall, etc., typically on a held-out validation set. Finally, model validation is a more rigorous check, ensuring the model meets certain quality or business thresholds before it can move forward. This top section represents the experimentation environment. This is where data scientists and ML engineers do their initial, often ad hoc, work. Tools like Jupyter Notebooks are common here for data analysis, exploring the data, and quickly trying out new ideas or model architectures. They'll run the ML training pipeline here, but the focus is on rapid iteration, trying different hyperparameters, or testing new feature ideas. It's less about production readiness and more about discovery. Successful experiments from here might inform changes back in the feature store, the data pipelines, or lead to more structured work in the development environment. Below that is the development environment. This is where the experiments that showed promise get turned into more robust, reproducible code and pipelines. Tools like Kubeflow or other workflow orchestrators, like Argo, mentioned later, are used here to define and run the same ML training pipeline steps, but as automated workflows. The goal here is reproducibility, making sure the pipeline runs consistently every time with specific data versions and code. This makes collaboration easier and is a necessary step towards production. This environment is often triggered on pull request. When a developer submits code changes, automated systems, like Jenkins or Circle CI, distributed processing tools like Spark or Dask are often needed behind the data retrieval and pre-processing steps when dealing with large datasets that don't fit into memory on a single machine. Orchestration and CI/CD systems, like Kubeflow, Argo, Jenkins, Circle CI, automate the running of these pipelines, manage deployments, and integrate everything into a smooth, automated workflow triggered by code changes or schedules. And don't forget to subscribe for more deep dives into MLOps and data science practices. Thanks for watching, and I'll see you in the next video.